For my discussion number one, I'm going to be going and be discussing the muscular morphological adaptations to anaerobic training. So basically, muscular morphological adaptation refers to changes in the structure and size of muscles. Typically, what that means is a response to training of stress. These changes can involve increasing muscle size, which is basically hypertrophy. In other words, changes in muscle architecture or shifts in muscle and fiber type as well. The chronic physiological adaptations that are specific to anaerobic training program and occur to the neural and muscular and also endocrine system. So the chronic and physiological adaptations that occur are specific to the anaerobic training program and it can occur to the neural, muscular, and endocrine system. So, anaerobic training involves a lot of high intensity type of workouts, which is short durations, quick muscle fibers efforts, such as, sprinting, heavyweight resistance training, plyometrics, and, high intensity interval training, such as like, football training, when players are doing back drills, they're doing one exercise after another, which requires a short burst of energy production without relying on any oxygen. So no rest time, very minimal rest time. You're using a lot of, uh, ATP system for that type of training. So this training places extreme mechanical and metabolic stress on skeletal muscles, leading to a variety of structural or morphological adaptations. These adaptations improve the muscle's ability to generate force, resist fatigue in short duration efforts, and store energy and substrates. So, these apps basically moving to muscle hypertrophy. So, which gonna be like one of the first adaptations when it comes to morphological adaptations for anaerobic training. So, muscular changes, especially hypertrophy, are typically the most emphasized and desired changes when it comes to the anaerobic training and benefits. It is the most visible adaptation to anaerobic training because whenever you see someone who's very muscular and big, you can see that they're however increasing in size. It's very, very, very noticeable. And that's the most desired because it brings a lot of intrinsic motivation. When someone sees themselves in the mirror, they see that they're very big and seeing that they're getting a lot of muscle fibers and increase in size. Which is also primarily within the type 2 fibers. So hypertrophy is driven by mechanical overload, which causes micro tears in muscle fibers. In response to the body repairs and rebuilds the tissue with additional contractile proteins, primarily actin and myosin. So whenever the body breaks down, actin and myosin helps body can build those muscles back up and repairs. Therefore, that's why you build a that's how you achieve hypertrophy and with the mechanical overload. So type 2 muscle fibers, especially type 2, 2A and 2X, are more prone to hypertrophy because they're recruited during high intensity movements, which is basically recruited through anaerobic type of training. So they're fast twitch fibers specialized for power and speed. This increase in cross sectional area enhances the muscle's ability to generate force over time. So the progressive overload, these fibers become thicker and and denser. Hormonal responses um, also play a role. Anabolic hormones, are such as testosterone growth hormone and IGF, which is insulin-like growth factors, promote protein synthesis and satellite cell activates. Now we're gonna be moving on to the second second adaptation, which would be muscle fiber type transitions. So it is the transition between muscle fiber types, specifically from type 2X and type 2A. Type 2X fibers are fast and powerful but fatigue very quickly. With training, many of these fibers convert to the more fatigue resistance type 2A phenotype, which still generates high force but can sustain it longer. Uh, this shift reflects the muscle adapting to the demands of repeated high intensity bouts, improving power endurance. While we don't see the significant increases in type 1 fibers with anaerobic training, that does not mean that they don't actually increase still. The overall functional capacity of the muscle improves due to better recruitment and hydratization of type 2 fibers. So, we're still recruiting type 1 fibers, just not through anaerobic training, but just not as much. Now moving into the third adaptation, which can be microbiliary density and sarcomere in addition. So, myofibrils are the contract units of muscle fibers composed of actin and myosin filaments. Through anaerobic training, increases the number of myofibrils in each fiber, a process called the myofibrillator hypertrophy. This differs from sarcoplasmic hypertrophy, which is more about fluid glycogen accumulation. Myofibrillary hypertrophy is also directly contributes to also strength. Anaerobic training plays a lot of importance in power and strength because it promotes a lot of all those fibers. You know, and additionally, more sarcomere, the functional units of contraction, are added to parallel increasing force output. The denser contractile of packing allows muscles to produce more tension and withstand greater greater loads. Greater loads. So now we're gonna be moving on into the fourth adaptation, which is gonna be increased connective tissue strength. So which is gonna be a lot of um you know whenever we have our skeletal muscles, we're with anaerobic training, we will be increasing skeletal muscle strength and also muscle strength, like muscular strength as well within the muscular system. So muscle growth must be supported by strong connective tissue. Anaerobic training stimulates increased collagen synthesis in tendons, ligaments, and the extracellular matrix. Tendons become stiffer, thicker, improving the efficiency of force transition from muscle to bone. This adaptation enhances the joint stability of the body and reduces injury risk. So, especially in athletes, you see this a more, when compared to athletes compared to players that are not as mobile. Let's say, for example, like as let's say, like as let's compare a CrossFitter to someone who exercises just for health and wellness. The fascia connective tissue around the muscles may be it will be thicker compared to an athlete compared to someone who just works out for health and fitness because they are lifting heavier loads. Athletes are tend to lift heavier loads to build that power and strength to translate to the human performance into the playing field. So the fascia connective tissue surrounding muscles is also thick and improving force coordination across muscle groups. Now we're going to be moving to the fifth muscular adaptation. Is going to be enzymatic and metabolic adaptations. So on a cellular level, anaerobic training unregulates enzymes that support rapid energy production through glycolysis. But also key enzymes include, PFK, which stands for fact. I can't correct me. This is I have pronounced hardness, but it's phosphofructinases or phosphofructinases. I really have a hard time saying it, but also lactate dehydrogenase, which is creatine kinase. These facilitates faster breakdown of glucose and faster creatine to meet energy demands. Although anaerobic training does not enhance um, mitochondrial density as much as aerobic training, it also does improve muscles' ability to buffer and tolerate lactic acid through increased lactic transporters and buffering proteins like kerosene, which also allows the body to sustain high intensity work for a longer period of time before fatigue sets in. Now moving to the sixth muscular adaptation, which is gonna be muscle architecture adaptations. We know so muscle architecture is the arrangement of muscle fibers. They also adapts to anaerobic training. One key change is increase the pennation angle, which is the angle which the fibers insert to the tendon. So larger pennation angles also allow muscles fibers to fit in a given area, increasing force production. So fascicle length, the length of an individual muscle fiber bundles may also increase, improving contraction velocity and power output. So these architectural shifts enhance muscles and mechanical efficiency for efficiency tasks like jumping, sprinting, high like going to sprinting, doing anything that's like really short bursts of movements that require a lot of the bodies of quick muscle movements for which consider high intensity training and used for anaerobic type style training. So now moving into the the last one for muscular adaptations with anaerobic training, morphological adaptations. So intramuscular substrate storage, anaerobic performance relies heavily on stored energy substrates. Resistance sprint training increase intramuscular intramuscular stores of ATP, which is going to be the actin triophosphate, and glycogen phosphate creatine is the fastest source of ATP resynthesis during maximal efforts. Increasing its availability helps maintain performance during repeated sprints or heavy lifts or anything has to do with anaerobic style type share where it cuts just small short bursts. Glycogen also is essential for sustaining activity up to 60 seconds. So like a fit maybe like a CrossFit training, where you're doing a lot of intervals and different rounds of training, for 60 seconds. Glycogen is essential for sustained activity. For like it's like a 60 second. That's when glycogen kicks in after the ATP store has been used. So trained muscles store more glycogen, enabling longer anaerobic uh, burst bouts of depletion. There's a substrate adaptations improve energy availability and delay of onset of fatigue and shorter intensive efforts. So basically, just to say more about the morphological adaptations, anaerobic training leads to profound structural adaptation, skeletal muscle, and improved strength and power and high intensity endurance. Key things to say: increasing muscle fiber size. Uh, not only that, there's using different systems, so like glycolic enzyme activity, improve for architecture, and creates a substrate energy. Do you use different energy compared to aerobic, where you're using more of an oxygenated system, using oxygen. Uh, these adaptations perform more forcefully and efficiently during aerobic tasks, making them essential for athletes in power and speed based sports like track when it comes to sprinting, football. Like a offensive lineman is blocking in person. They're only blocking for only a short burst of time until the play finishes. You know, these changes are very crucial for designing effective strength and conditioning programs that optimize muscle function and reduce injury risk. Learning how to program these exercises within the right proper types of training within repetitions and sets. So that concludes video one. Hopefully, I fully explained very well about the adaptations. When it comes to muscular morphological for anaerobic training. So that will conclude the video, and we'll be moving on to my either other ones given.